Right, so let's talk about factors. The factor is a data structure which is very useful when you try to represent a categorical data or nominal data. Okay, and to create a factor, all you need is a function called a factor. Okay, so if you know more details about factor, all you have to do is, as usual, question mark and type factor. And then you can get all the details about factors. All right. So let's create a factor. Okay. So let's let's create a vector using remember combine function C. So here we have a data about hair colors, black, blonde, brown, purple, red, and red. Okay. So now we have a vector called the hair. So when you look at the data in hair, so we have what we just saw, black, blonde, brown, and so on. Okay, let's take a look at the data type. So obviously it's the character. Can you see that? It's a string surrounded by the double quotes. So it's a character data type. So to create a factor, it's not that difficult. All you have to do is the factor and then the vector over here. So if you do that, now we have a hair factor. Okay, as you can see over here, can you see the difference? So when hair was a vector, we had all the data from black all the way to red. But once we change it to the factor, so now we have information about levels. Okay, levels. But basically, what that means is these are the possible values or categories you could have in the vector. So black, blonde, brown, purple, and red. In actual data, we have two browns and two red. But in terms of actual categories, we had black, blonde, brown, purple, and red. So 1, 2, 3, and 4, 5 levels. Okay. Okay. So once you have that, and we can also use the index to get a particular value. Okay. So remember, in our index, the index value start with 1 rather than 0. Okay, so what this means is give me the third value, third element in the hair factor. So that is a brown, as you can see over here. So we have 1, 2, 3. So brown. Okay, the fourth one is obviously another brown. Okay, in a nominal data, there's no order among the values. Okay. So when you try to compare whether hair, hair 3, which was brown, and you try to compare with the hair 4, which is also brown, this one doesn't make any sense, right? So as you can see over here, warning message, okay, it's not meaningful. Okay, so you can also try a different the values. Okay, so how about the blonde? Okay, so blonde less than brown. Okay, let's take a look. Obviously the same thing. In nominal data, doesn't make any sense. Okay, to compare those categories. Okay. We can also use the factors to represent ordinal data. So let's take a look. And when you have some nominal data, such as the size of the the quote, so some are medium, small, X large, medium, double X, things like that. Okay. So these are actually nominal data, but actually we see some order here. So the medium is larger than medium, large is larger than medium, X large is larger than medium, and so on. Or the grades like A, B, C, D, E those are nominal data, but also A is better than B, B is better than C, C is better than D, or things like that. Okay, so let's create the factors. So first we have to create a vector. Okay, so we have a vector of M, S, X, M, double X. Okay, so we have data here, and what's happening here? And so let's look at the data X we just created. Okay, so here we have a vector MS having a MS X M double X. Okay, to create a factor, all you have to do is to say factor and then vector of the sizes. Okay, so now we have the vector, the factor of sizes. Okay, and as you can see over here, the levels are M, S, X, double X, and those levels actually from this vector. Okay, but sometimes we can actually have more complete levels, or levels which may not exist in existing factors. And to do that, you can actually specify the levels explicitly. Okay, so here when you create a factor sizes, you can specify the levels like S, M, L, X, double X. Okay, and then if you do that, so now we have levels S, M, L, X, and XX. Just like a usual factors, you can use the index value to get the value from a factor. Okay, the first one is M, medium, as we expected. The second one was S. Okay, so let's try to compare. The one is greater than or 2, like a medium is greater than small. So probably that's what we may have in mind. Okay, so let's do that. So doesn't work, because the default, when you create a factor, the default is there's no order among those nominal values. Okay, so let's check whether they actually have an order or not. The function is dot ordered. Okay, or false. So actually they are not ordered. Okay, so if you want to give an order, all you have to do is s dot ordered. Okay, and then they will order those nominal values. Okay, all right, so let's take a look. So we have as you can see over here, can you see the levels? Okay, so now you can see order. So S is less than M, M is less than X, X is less than double X. Okay, so now when you compare whether the size is 1, which had M, medium, is greater than size is 2, which had a small, we can actually compare those values. Okay, so it's a true. All right. All right, so let's take a look at another example. Okay, so this time we're going to have data about people. Okay, so let's create a vector of age groups: young, middle-aged, and old. Okay, so this one we're going to use this group for the levels. Okay, so here we have a young, middle-aged, and old. Okay, and let's create a vector of these people: young, middle-aged, middle-aged, and old. Okay, and so using this the data, we're going to create a factor. Okay, and but this time we are going to specify the levels. Okay, we're going to specify the levels with this vector. Okay, age group. Okay. Okay, so let's look at it. So we have now a factor app people, and the levels are young, middle-aged, and old. Okay, and just like in the previous example, we can take out the value depending on their location. So let's get the first one as a young. Okay, the third one, that is what, the middle-aged. Okay, so we probably think there's some order between young, middle-aged, and old. So let's compare the second one with the third one. The second one is young, the third one is middle-aged. So this may or may not be the case. Okay, so let's do that. It says, well, it's not meaningful for factors to compare these two values. So what that means is what? We don't have any order. So we can actually give them an order, okay, by ages. Okay, to do that, all you need is as ordered and the factor F people. Okay, so now we have F people is ordered. So if you want to check whether it's actually ordered or not, as I showed you previously, you can take a look. So now F people is actually ordered. Can you see that is ordered? Actually true. All right. So let's compare them. So F people 2, which is what, young? No. Young, and is less than 3, which is what? Middle-aged. Okay. Let's check it's true or not. It's a true. It works. Okay. And how about this one? Equality comparison. And the first one, which is young, let's take a look. So the first one is young, second one is young, and so on. Okay. So when you compare the first one with the second one, it's gotta be true, right? Okay. It's a true. All right. How about third one? Middle-aged is less than young. Let's take a look. It's a false, right? The order we have is what? Young, middle-aged, and old. Okay, so all right. So does that work? Can you see that? The order: young, less than middle-aged, middle-aged, less than old. Okay. All right. So we can actually represent now nominal data and also ordinal data. So in case of ordinal data, all you have to do is specify those levels are ordered. Okay. Actually, in R, those orders and the levels are represented as numbers. So let's take a look. So see the actual numbers like 1, 1, 2, 2, 2, 3. So young, middle-aged, and old. So basically, they use these numbers to compare the values. Okay. All right. So if you actually want to specify the factor from the beginning, and you can actually do it this way. So whatever the factor you have, okay, and then you specify the levels. And then you can say ordered true. Okay. The default was false. Okay. So previously we actually did it like that. But actually, from the beginning, you can give an order. Okay, again, the factor and the data and the levels and whether you want to have them ordered or not. Okay, so you can do that. And let's look at F people 2. So you can see order. Can you see that? You can see the order and those values. All right.